All right, so today we are saying goodbye to all that fun trig stuff and moving on to statistics, which I think is just as cool. But I'm a nerd, so that's okay. So, theoretical probability, what we're talking about here is pretty much the definition of probability is how likely an event is to occur. And the set of all possible outcomes is called your sample space. Sometimes you'll hear me just call it as the sample. For equally likely outcomes, the theoretical probability of an event is the ratio of the favorable outcomes to the total number of outcomes. Okay, so if I was doing something as simple as asking you, what's the probability of me rolling a 1 on a 6-sided die? Well, the total outcomes would be 6. There's 6 spaces, and there's only one on the die, so that'll be 1 out of 6. So ratio, fraction, same sort of thing. That's what we're talking about with probability. This is hopefully something really simple for you, especially these simple events. That's kind of why they call it that. So a jar containing 32 red and 28 blue marbles. What's the probability that a randomly selected marble is red? So we have 60 marbles total, so that's your sample. And then what's the probability that you pick a red, which is 32? So you put the favored over your sample. In other words, what you're looking for over how many there are. And then you can just simplify that out, and that'll give you 8 over 15. Sometimes people use probability as percentages, so that's perfectly fine if you want to divide 8 by 15 and get that percentage. I'm not going to worry about it. As long as you give me a simplified fraction, I'm perfectly fine with that. But don't leave it as 32 over 60. Definitely don't do that. So, a day in the month of January is randomly selected. Well, there's 31 days in January. What's the probability of selecting a prime number? That's going to be a lot of fun. So we have 1, 2, 3, 5, 7, 8, 9, 10, 11, 12, 13. Obviously, we're not going to have any even ones after 2. 14, 15 is able, 16, 17. I should have picked this instead of, or I've done it already. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, so that looks like 11 prime numbers. So that took a little while. Sorry for that. Maybe I should have picked a better one. But I do want to go over number 5 because not many people know about a standard deck of cards. So pretty much in a deck of cards, you have spades, you have clubs, and they are both black, and then you have hearts, and you have diamonds, and they are both red. Okay, so if it's asking you for the probability of getting a black card, then it's 1 out of 2, right? Of probability of a red card, then it's 1 out of 2. If they ask you for the probability of drawing a heart, then it's 1 out of 4. Okay, but in each set we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it doesn't go to 11. It goes jack, queen, king. Okay, so there's 13 in each set, and some of you guys are like, really? People don't know cards? You'd be surprised. So just trying to cover it for everybody. If you haven't, you should really learn how to play cards. There's tons of different games. It's loads of fun. Me and my family do it all the time. But yeah, so there's 13 in each, which 4 suits, that makes 52 cards. Okay, so what's the probability of drawing a heart or a club from a standard deck of cards? So how many hearts are there? There's 13. How many clubs are there? There's 13. That's 26 out of 52 total, which is 1/2. All right. So then we have the complement of an event. Hopefully that was pretty simple for you guys. A complement may be a little different. So the complement is the probability of the event not happening. And since the sum of all the probabilities in a sample space is 1, what we're going to do is to find the complement, which this little like squiggly mark that almost looks like our similar symbol, that means not. Okay, that's the complement of this event happening. And what you'll do is you'll take the probability of the event happening and subtracting it from 1. Okay, so the probability that it will snow tomorrow is 7 out of 20. So that's the probability that it does snow. The probability that it doesn't, we're just going to subtract 1 from that. Okay, so that would be 20 out of 20. So you see how 20 out of 20 is the total possibilities, or the total probability. So it will be 1. And then you just subtract that from 7, and that will give you 13 out of 20. Okay, a month out of the year is randomly selected. There are 12 months out of the year. What's the probability of getting a month that does not begin with the letter A? So first off, we're going to find the probability of getting a month with the letter A. So it'll be April, May, June, July, August, just April, right? Am I wrong? August. Oh my goodness. Wow. I was looking and I just stopped at July. That's kind of embarrassing. So 1 minus 2 over 12, and that will be 10 out of 12. So the other months, and that will be 5 out of 6. Yeah, we're just going to move on from that. It happens. So if the spinner to the left, which has 16 spaces, is spun, find the probability that it lands on a number that is not prime. Okay, so we listed our prime numbers earlier. So these will be the ones that are below 16 that we would see on there. So that will be 7 of them that are prime out of 16. So to find the ones that are not, we're going to subtract 1 from that, and that would be, let's see here, is that right? 1, 2, 3. Yeah. So then we subtract that, and there will be 9 out of 16. Okay. Keep moving forward from there. Compound events, independent and dependent events. Yeah, I really look at my prime number. I'm not comfortable with that, but that's okay. So, compound event. This is 2 or more events, and they can either be independent or dependent. So, independent is when the outcome of one event does not affect the outcome of another. But then dependent is when it does affect it. So, an example of a independent event. Well, what we're going to do with these is we're going to multiply them. Let me go ahead and write that out. But example of this would be like rolling a die and tossing a coin, okay? So if I toss a coin and it lands on heads, that has nothing to do with the die. It will not affect the die at all, right? But say with dependent events, I have a bag of marbles, and I take one marble out and I do not replace it. So this says without replacement. Then that's going to change, right? Because there's one less sample space. There's one less sample in there, and that probability is going to change. It does affect it. And you'll see this. This is a lot easier to show a little later on. But that will be the probability of A multiplied by the probability of B after A has occurred. Okay, so with independent, it's really nice and easy. You just multiply them out. A die is rolled 3 times. What's the probability of getting 1s on each roll? For the first one, probability is 1 out of 6. Nothing changes. You pick it back up, still 1 out of 6. And one more time, 1 out of 6. When you multiply those together, that will be 1 over 216. So that's your probability of getting a 1 every single time. All right, so a coin is tossed, and then a day of the week is selected. These are still independent events. What's the probability of getting tails? 1/2. And then a day starting with a letter T. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So that will be 2 out of 7. You just multiply those out, 2 over 14, which will give you 1/7. So there's your probability there. The coin being tossed and the day of the week have nothing to do with one another, right? So for this next example, we have a bag containing red, purple, yellow, and green crayons. Now the biggest thing here is that the crayon is selected and replaced. Okay, so imagine that I have a bag and I take a crayon out and then I put it back in. The sample does not change because there's still that many amount of crayons on here, right? So to start out with, we have 8, 14, 6, and 4. So that will be 32 crayons. All right, so what's the probability of getting a purple? Well, purple would be 14 out of 32, and we multiply that by the probability of getting a yellow. So we take that purple crayon, put it back in. So out of those 6 yellow, there are still 32 crayons in there. When you multiply that out, and simplify it, that'll be 21 over 256. Okay, so we could do the same thing with 2 yellows, right? What's the probability of taking out a yellow, replacing it, and then taking out another yellow. So that probability, when simplified down, will be 9 over 256. Now the dependent event here is a little different. So using the same sample from above, assume that once a crayon is selected, it is not replaced. Okay, so for number 17, the probability of getting a yellow, there's 6 yellow out of those 32, but then we do not replace that yellow, so now there's only 31 crayons left. So the probability of getting a yellow and then a red, well, there's still 8 red left. We didn't take out a red, we just took out a yellow, right? So then you'd multiply that out and simplify it. That will give you 3 over 62, right? And then you can also do 2 reds, right? So the probability of getting a red to start out with is 8 out of 32. There's 32 total crayons. There's 8 of them red. So we take that red out and we do not replace it. So now there's 31 left, and there's only 7 red left. So you need to multiply and subtract 1 from each of those. That will leave you with 7 over 124. You can do the same sort of thing with the greens. There's 4 green out of 32. You do not replace the first green, so now there's 3 greens and only 31 remaining. 3 out of 248 will be your simplified fraction there. Okay, so for 21, a card is drawn from a standard deck, not replaced, right? So this is dependent, and another is drawn. What's the probability of choosing a heart and then a spade? So there's 52 cards in a deck, and the probability of getting a heart is 13 out of 52. Then we will multiply that by the probability of getting a spade. So there's still 13 spades, but we'd have 1 less card in the deck, right? So 13 over 52 times 13 over 51, simplified out, will be 13 over 204. All right, for number 22, Jack had 4 Snickers and 8 Mars bars. He randomly chose a piece of candy, ate it, obviously did not replace it, and chose another. So what's the probability that both of them were Snickers? He has 12 total. He has 4 Snickers to start out with. He eats a Snickers, so now there's 11 candy bars left and only 3. So that is our probability of A and B. Multiply those out, and it is 1 over 11. Okay, so if you got any questions with this, feel free to reach out and shoot me an email. I'll go back and look over these. Maybe I may have messed up. I think number 9, they had a different answer than what I did on the answer key, but that doesn't necessarily mean it's true. A lot of times they can just make mistakes too. But I'm also humble enough to admit that I may have made a mistake. But I think I'm right. We'll see. Anyways, shoot me an email if you got any questions. Hope you